last session, we were together. We were introducing discrete event simulation, right? So in a way, the introduction was about simulating your process, right? Your real life process virtually, right? And we also went on to talk about applications of this of discrete event simulation, right? From just-in-time, supply chain, manufacturing, you name it. Everything that has to, almost everything that has to do with the process can be modeled using discrete event simulation, right? So, and yeah, I remember the last session we built a basic model of a mini process within a supermarket, right? That modeled the checkout process, right, in a supermarket. So from when the customer when the customer is at the till and checks out whatever they bought with the cashier, and from up until they exit the store, right? But we'll build that model again and actually run it and see the statistics, the descriptive statistics that are produced by the model, right? We couldn't do that because there was a package in the software that was missing, so we couldn't see Arena at its full force, if I can put it like that, right? So yeah, for today, we're just gonna build that basic model and go to a more intermediate model, and then that'll be it for the session, right? I believe we'll have 2 sessions, today and next week, and after next week, you shall be ready for the lab test, right? Just a side note, it's a crash course, right? In a way. So after these 2 sessions, you will be better equipped in terms of using Arena, but you won't be a master, right? Obviously, because of time constraints. But I can also say that I urge you to explore it further because it's a very powerful software. And yeah. Anyway, if you can go ahead and open your Arena software. So yeah, for those interested in which software we're using, am I sharing my screen? I think I'm not sharing my screen. Let me share my screen with the guys that side. I always forget this. Screen, entire screen, share. Okay, okay, yeah, I hope everyone can see my screen. So anyway, I'm gonna open Arena and my lab guide. So this lab guide will share it with you once we are done with all the exercises, right? So I won't be sharing it like today, but once we are done with everything that is needed to be covered, right? I'm just gonna hide this. Okay. I'm also gonna quickly open my lab guides. Okay, there is my lab guide. Okay. And one might ask themselves, why do we need to simulate, right? Just a few reasons. Using your actual system, using an actual system or a real life system performing a simulation. At times it can be costly, right? At times you do not have the liberty of experimenting with your products. Some products are expensive, right? So you cannot just run simulations on real life products because of the cost side of things, right? And the other reason is also it is less time consuming. You can actually simulate your model to run over like whatever amount of time you want. You can simulate it for 10 days to see what would be the output for 10 days, right? You can simulate it for maybe 30 hours, right? And get an output there and there, right? And whereas in real life, it's more time consuming, right? Resource consuming, money, it consumes money, and yeah. So those are one of the few reasons why it's better to create a model. Right? Now, without wasting time, I'm just gonna, so this is lab guide, and we're gonna just go through the basic model that we went through in the previous class, right? And just so that we can see, the analysis, right? So I'm just gonna read quickly over this. So in this basic example, the simulation is based on a sub-process that happens in the supermarket. That is customer arrival and the checking out of products by the assistance of a cashier and the exit of the customer. The simulation aims to identify the average queuing time in a single till, along with resource utilization, average waiting time of the customer. Cashier downtime or changeover is not considered for this simulation, right? Although that scenario can be simulated if a user desires to. So for this model, the modules to use are create, entity, process, and disposal. The create flowchart module works as follows, right? The create module is used at the beginning of every simulation, and the module is used by the user or modeler to define what the process is about, right? Entity flowchart module. Entity flowchart is with respect to the object. In this case, it's our cashier passing through the system or the object being taken through the process. So for this example, the entity is the customer. And we have your process flowchart module. In this module, the user specifies the action taking place. For this basic model, we are experimenting on the process. We are experimenting on the process. We'll be checking out, so the process is checking out of products done by the resource, right? The resource is our cashier. That is the cashier. Disposal flowchart module. The disposal module indicates the final phase of the process. And for this simulation, the end of the process is when the customer exits the store, right? So I'm just gonna split my screens, right? Okay, so that I can see my lab guides. Okay, so for this process, we'll first go to data definition, right? So in your data definition, this is where you define your entity and your resource, right? Let me just make it a full screen. I'll go back to the website. So we're gonna define our entity. So if you can remember, our entity is our what's it called, customer, right? So we're just gonna click on it and we're gonna double click on that blank section there that says double click here to add a row. Right. Yeah, and it's good that I'm hearing clicking. It means people are busy. It's advisable that you also do what I'm doing. So our entity is customer, and then for initial picture, we can say picture of a person, right? And then, can someone please pause me? The people in this venue, or the person in this venue. Okay. Yeah, the people in the venue, they don't need to log in. But anyway, so the other columns there, we will not be covering, but they're with regards to holding costs, initial cost. Basically, it's your costing section, right, of which we will not really pay much attention into. But if you have data that has to do with like costing, you can put it in and run it through the model, right? Okay, so once we're done with our customer, with defining our customer, we can define our resource, right? We use the same methodology, right? You click on it and double click. So for this case, we have a singular resource, which is our cashier, right? Then the type is fixed capacity, and capacity is 1. So under capacity, this is where you define how many resources you need for that particular station, right? Then we're done with defining that, and then we can just close that by clicking on discrete processing, right? Okay, so if you can recall, every simulation begins with what we call a create module, right? So a create module, this is where you specify what is happening in your process, right? Your overview of your process. So here we can say customer checkout, right? Then you can say, okay, let me just see if it aligns with what I did in the, okay, customer arrival. So the process is customer arrival. And then the entity type, the entity linked to this create module is our customer, which we have defined. So if you can click on that drop down. Yes, we have a question. It's okay, it's okay. Okay, no problem. So data definition, it has to do with your entity and your resource, right, for this context. So with your entity, what you are defining is an object that is passing through the system, right? Maybe to put it in the context of maths, the subject of the formula. So that's your entity, right? In a maybe car assembly process, your entity might be a car, right? In a maybe bottling, in a context of like maybe manufacturing. Another context, I mean, another example might be maybe the filling in of Coca-Cola bottles. The Coke is your entity in that case. So basically, that object, your product, basically that is passing through your system. That is what we mean by your entity. Right? So I don't know if that's much clearer now. Okay, so what we did is we went to entity, right? You go to entity and you click on it. And then under your workspace where you design your flow diagram, you'll see a bunch of columns. And then in order to define that entity, you just double click on that white space underneath those columns. And then you'll see a row 1 created. If you can look there at the screen, there's a row created, and then under entity type, that is where we put in customer, right? And then we changed the initial picture to picture.person. So that is just the icon we will be seeing going through the system during simulation. Right? And then we leave the other columns. We're not really concerned with those columns. Then by doing that, you would have defined your entity. Are you okay? All right. Then next, we went on to define our resource. So in defining your resource, you do the same thing. You click on it, and then you double click, and then under the name column, that is where you put your cashier, and then the type is fixed capacity, and then the capacity is 1. So for this case, we are using 1 cashier. Right? So it's our customer interacting with the cashier. And then once we are done with that, we go to the discrete processing tab, right? So what I was saying here was that with every process that you are trying to model, you always start with a create module, right? And then we defined our create module to be, we named it as customer checkout. How you do that is you drag and drop onto your workspace, and then you double click, and then you'll see this pop up, and you will, what's this? You'll name it however you name it, but obviously name it in an appropriate fashion, right? Now, the other important thing when you are configuring your create module is that under entity type, you have to link it to the entity. So your create module, you have to link it to your entity, right? And then you click on it like that, right? Then after that, we have time between arrivals, right? So what this means is that we are saying, so we are using, so we are saying how many arrivals at a time, right, into our supermarket, right? So for this, we under type, we select random expo, right? Yeah, the other ones you can maybe in your spare time just play around with them as to what they mean. But like if I can click on maybe schedule, it's okay, it's something different. But and okay, constant. Okay, constant also involves putting in your time, and expression is something different, right? But for this case, we're using random, right? So we're saying how our customer arrives into the supermarket is on a random basis, right? And we are saying after how long do they enter the supermarket, right? So for according to this, let me just check the log guide, what I prepared. Okay, so I said every 0.5 minutes, that is every 30 seconds, a customer arrives into our supermarket, right? And just remember, this is like dummy data, right? In your case, you would need to go through your real life data and put in maybe an average as to after how many minutes do your customers enter into the supermarket, right? Okay, and then entities per arrival, we're saying 1 customer enters per arrival, and the maximum number of arrivals, we're saying for this simulation, we're gonna say, let me see. Okay, we're gonna just leave it at. I'm just gonna say 50, right? In a day in our store, only 50 customers come, right? Come into our store, right? And then you're gonna leave first creation as is, and then you're gonna click OK. And then we're done with configuring our create module. So next is the process, right? I didn't change this, so it's customer. Our customer will arrive and they will buy whatever they buy, and then they'll come to the cashier, right, to the till, where they will pay to get their things, right. So here we're saying this is the checkout. This phase of the process is the checkout, right? And then the type we leave as is, standard. And then the action, the logic action is seize, delay, release, right? And if you can remember, in the previous session, I said what this means is your entity will arrive at the at the at the till, and then your entity will interact with your with your resource, that is the customer interacting with the cashier, and that will be the delay, and then the release is when your resource is free to serve another customer, right? So you almost always use seize, delay, and release. And let me just say, in our case, we will always be using seize, delay, and release, right? Okay, then once you're done with that, you will assign your resource to your process, right? Remember, we are on the process module. Then you'll click add. Then under type there, you'll click on that drop down, or actually under the resource name, you'll click on that drop down, and then that's where you'll see your cashier there, right? Then you'll select the cashier, and units to seize, it's just one. Then you click OK, it's always one. Then you click OK, unless stated otherwise, right? Then the delay type is triangular, and then the units are in minutes, and then allocation, you leave it as is. Then let me just go to this thing, to the lab guide. Okay, so your, what's this? Yes. Yeah, as I said, you will get the lab guide once we're done with all the exercises. Okay, so your triangular delay type, it will give you 3 parameters: minimum, most likely, and maximum. So what these mean is that this is the minimum, minimum means that it's okay, we assigned minimum to 0.5 minutes, right? By that we mean that the minimum time that the cashier takes to service a customer is 0.5 minutes or 30 seconds, right? But also we're saying most likely the cashier will take 1 minute to service our our customer, right? And then if the most time that the cashier will take in servicing our customer will be 1.5 minutes, right? Now remember, in your case, if it's a real life case, you'll use real data that you collected, right? And then you can just click OK, right? Yeah, I'm gonna click OK. Let me see if I did everything. So yeah, it's always good to check if your units are consistent. Remember that in the create module, we're using units, we're using minutes for our units, right? So always remain consistent. Otherwise, you will get what's this? A simulation that doesn't give you accurate results. Okay, so we can click OK. And the guys online, when I'm working on when I'm using the software, I can't really see your comments, but don't be shy to comment. Once I'm done with the simulation, I'll go back and I will cater to your questions. Okay. Lastly, once the customer is done with their cash out, they leave, right? They leave the supermarket. How you show that is by using a dispose function or a dispose module, right? So we can just name it customer leaves, and then you can click OK. And yeah, just the side notes underneath most of the modules, there are comments. Comments, it's just for yourself and maybe another what's this? Another technician, if I can put it like that, who you want going through your work to see how you are reasoning and whatnot, right? And then I'm just gonna click OK. Okay, so once we're done with that, before we run our simulation, we're going to go to the Run tab at the top there. We're gonna go to the Run tab. Then we're gonna go to the last on the settings group there. We're gonna click on Setup. It has an icon of that looks like a gear there. You're gonna click on it. Then you're gonna go to what's this? Is it project parameters? It's replication parameters, right? And then you're gonna say number of replications. So number of replications, it has to do with how many cycles do you want to run your simulation, right? Think about it this way: if you are like in quality control, it's basically maybe like the number of samples you want to take. Yeah, so think about it in that context, right? So for this case, number of replications is we just want to do one replication, and then warm-up period, we're gonna just say minutes, and replication length, we're gonna just stick to minutes, and yeah, replication length, it can stick to infinite, and then hours per day. So say we are modeling for an 8-hour shift, right? Normally our cashiers, they work 8-hour shifts, if I'm not mistaken. 12. Okay, someone has experience, I'll say 12. 12, I didn't know that. Thanks for that. And then base time units, we can say minutes, not we can say. We should stick to, should be consistent, minutes, right? And then once you're done with that, be sure to say apply at the bottom there and click OK. Okay, then we are ready to run our simulation. Now, before we click play, there's a toggle there at the top, right? So that is to regulate the speed at which your simulation runs, right? So for this case, we're just gonna bring it almost at the beginning there. So this means that it will this is the speed factor. This means that your animation will run slow, so it will be slow to finish your simulation. But remember when I said that you can set this at 24 hours, 30 hours, or even days, right? But you can have your results as quick as you want. So how you get that done is by using this this speed factor to and set it however you want, so that you can get your results as quick as you want, right? So we just want to see what's actually happening. So that's why I'm dragging it to the beginning there, right? So with that done, we are ready to run our simulation. So on the Run tab where we are, we'll go there to the top left and click Go. And then what you'll see is the animation there, like it's a symbol of a person, right? And then so then in the middle, what you saw, if you were observing, where there was checkout, there were icons of people, and then but there were also icons of people passing through the checkout. What that means is that's where the queues were happening. So where there were like stagnant people icons, that's where what you call, there were queues, right? But you will see that with the analysis. So if you click yes, I'm sure today we'll be able to see the analysis as we fixed our software. Okay, okay. So if you can click on the tab at the top, that's what I did, so that it can show me this report. So if you can click that at the top, you'll see this. Does everybody see this first page? No, yes. So you don't see this. Yeah, the lady there has done it successfully there. Also the lady here. Who else? Yeah, also the two guys there. Can you help the other guys next to you on how they can see? Huh? Can you see? Are you fine? Okay. The guys that side, are you fine? Okay. Okay, we're just gonna wait before we check out the descriptive analysis done by the software. Okay, so the guys that are still behind, they'll just have to check out the recording. Yeah, they'll just have to follow what we did in the recording, right? But I'm just gonna go ahead, right? So let's check out the descriptive analysis, right? So the first things first, on this page, we can appreciate that the model also shows the timestamp of when you started your simulation, and under key performance indicators, we have number out. So number out, it's that 50 customers we what's this? We set, right? Under our parameters, right? And then the replication is 1, and then yeah, it says our time units are seconds, but we're keeping 2 minutes, right? So yeah, if we can click on activity areas, you'll find nothing. And then under okay, category overview, it's what we just saw now. Okay, so if you can see, if you can click on category by replication, right? You'll see some interesting data, right? Let me see if I can adjust so that we can. Okay, so under time there, so we have your entity, right? On this page, it analyzes what happens to your customer, right? So under time, we have VA time. VA time is your value added time, and the average is 63.6688. So this is when the cashier this is when the customer is being engaged by the cashier, right? And on average, we can see that it takes just over a minute, right? For the cashier. Yes. How did we get here? It's because of everything we were inputting in our modules. So all these, okay, okay, I understand. So, ladies and gentlemen, this software, it runs on a stochastic model, meaning it runs on a random model. So all these values it calculates based on that random algorithm, basically. So how can I put it? So, well, we're not saying every time every time our customer will we're not saying every time our cashier will take 1 minute 3 seconds to service a customer. No, but like it simulates within close range. Like it is not fully accurate, but it is accurate to a certain area of margin, if I can put it like that. So yeah, that's how best I can explain that. I don't know if you understand that. Uh-huh. Okay, so if you can go to your report, on your report on the left there, if you can click on category by replication, you will see this window that we are seeing now. Can you see it now? Can you see it? Okay, so the other stat there on value at a time is minimum there. Under minimum, we're saying that when we say the cashier was quick, it's when they used only 32.5 seconds in servicing the cashier, right? And then the most time that the cashier will take in servicing our customer is 88.44 seconds, or you can say 1 minute 28 seconds, right? And change, right? And then there's nothing on the non-value adding time. Then another interesting what's this parameter is wait time, right? So based on this simulation, the average time that the customer waits is 836.90 seconds. Yes. Our minimum and maximum values also shows that 0.54. Yes, remember when I said that this software runs on a random algorithm, it's not gonna do the same for everyone. That's one thing you should note. So even in the case of a lab test, I will respect that. Like I will respect that when I see maybe different outputs for you guys. But I want to see if like you did input the parameters that I instructed you to input. Right? But I do understand that. Okay, so on the wait time, our customer waits on average 836.90 seconds. As I said, this thing it's defaulted to seconds. I don't know why, right? But it should be minutes. So, but you're engineers, you know how to convert to minutes. You'd have to divide that by 60 to get how many minutes on average that your customer waits in a queue, right? Let's just do that for interest sake, right? To put it into more context. Work later. So the software, on my part, my software is saying the customer waits on average 836.90 seconds. Right? If you divide that by 60, you'll find that a customer, according to this simulation, waits close to 14 minutes before they are serviced. And I'm sure you can relate, whoever shops at ShopRite, that sometimes, especially month end, you wait more or less this time before you are serviced. Am I correct? Or even wait longer? Yeah, so maybe if you shop at Woolworths, you wait short time. But I myself have witnessed that I can wait this much time before I get serviced. So, as an engineer, when you take this to your stakeholders or your manager, you can argue that it is unacceptable for our customer to wait 14 minutes before they get serviced, right? Because yeah, if I'm a customer, I don't want to wait that long. So you can argue and you can find, you can maybe brainstorm with your team a solution as to how we can reduce that time, right? One would say, let's add another station and get another cashier. There, and by doing that, we'll reduce the number of queues, right? But maybe someone will be like, okay, adding those resources, it's more money, and we do not have the budget for that. Then what? Then you can say that, let us investigate how our cashier is working. Is there something that causes them to work slowly? and hence disrupting, and hence causing the queue to be long and the waiting time to be long. Yeah, do they need more training to work more fast? Maybe this cashier is new and they're new to working with the system. Can you provide training so that they can better work more efficiently? You know, those are the kind of questions you need to take into consideration once you have all these results, right? Because once you have all these results, it's all great, it's numbers, but then what? How do you reduce those numbers, right? Into numbers that are better for everyone, the company and the customer, right? So that's the thought processes you should take into account when you are simulating, right? What else am I forgetting? But yeah, and also in a test, I might ask as to, based on your data, what is the proposed solution, right, to decrease the waiting time, the queues and whatnot, right? Okay, yeah, so we have your other parameters there, work in progress. Okay, so, okay, under other there, we have number in, number out, that is just to do with your customers. And then queue there, checkout queue. So this is what we were going through, right? Going back to other, work in progress, 14. Oh, okay, so that WIP, that average just means the average number of customers waiting in the queue. So we can see that it's 14.14. So the average number of customers that are in a queue are 14. And maximum, the model simulates to say 28. And yeah, we've seen this also in real life, that yeah, queues can even be 28 customers long, right? So we can explore other report. We can explore under entities. Let's see if there's something we can explore. Okay, so what's this? Non-value NVT, NVA, it's non-value adding time, right? So the total non-value adding time is 900.57 seconds. You can convert to minutes and see what that equates to. And we have the value adding time, right? Then yeah, that is another useful statistic. Under frequencies, there's nothing, and then processes, we have nothing. Queues. Okay, so yeah, basically this what's this? This just is a summary of your queues, right? Your checkout queue and number waiting in that queue, right? And then we can have resources. Okay, so so for cashier usage there, the number B's is 1, and yeah, the number B's is 1, and then number scheduled is 1 cashier, and then number seized, they engage with 50 customers. Then scheduled resource is 1, right? Then I think inst there it's just I forgot that parameter, but it's not really that important, right? Then transfers, there's nothing there. There's nothing there, thanks. Okay, so basically that is, I don't know why it doesn't do graphs. It used to, but I'll check that out. So it can also give you a visualization of your data in the form of bar charts, right? But yeah, we'll do that in the later phase, right? So yeah, can you go on? Can you go on with that? Okay. Okay, we're just gonna do the last exercise, and then we'll call it a good night, right? Oh, and how you save is you go to file, and then you can go to save as, file, save as. Okay, it's misbehaving. Oh, it's because, I think it's hard to save when you're in simulation mode. So when you want to save, just make sure you're out of simulation mode. And then you go to file, then save as. Okay, and then you will use your student number, surname and initials and saving your file. I'm just gonna say lab session 2. Lab session 2. And yes, I'm going to need you guys to submit a file of your in this format .doe. So I need the file to be in the format of your simulation, right? No screenshots. So lab session 2, and then you can choose wherever you want to save it, right? So for your test, just get in the habit of saving under thought space, right? Thought space enables you to retrieve your file should your PC, for example, maybe freeze or crash down, right? Crash. Then you can just say save. Then you have successfully saved your what you call your file. Okay. I'm now gonna open a new one where we do another example, right? Yeah. Okay. So you'll click on new, and then you'll click on blank model. I'm just gonna wait for everyone. I see they're still saving. Oh, everyone has opened a new file. So yeah, so you're gonna click on new and blank model. So as you can see, it says model 2. There's a new tab created, model 2. So you can actually see your previous models, right? But for this case, we're creating a new model. Okay. So the new model goes as follows. Okay, this might be an example that is that is maybe not intuitive because we are used to like manufacturing. So it's not really a manufacturing example. So it goes as follows. In this hospital case study, blood samples go to different departments. The simulation aims at identifying bottlenecks in the system when the blood samples travel between 3 departments. So the 3 departments are the blood bank department. So 50% of samples go to the blood bank department, 30% of samples go to the hematology department, and 20% of samples go to the chemistry department. So just like we did in the previous example, we're going to define our entities. So please go ahead and define those 3 entities. Wait. Sorry? Yeah, so the sample, actually, we have only one entity there, which is your sample, right? I was saying samples. I was thinking samples. So yeah, go to data definition, click on entity, and double click under the white space there, and click samples. Type samples. And then the picture will be of we can say a red ball. A red ball will symbolize the blood. Right? And yeah, you can actually download animation pictures that are fitting for whatever context. You can do that by going to the animate tab and going to edit entity pictures. Okay, but with this, I'll show you in the other lab session, right? So for today, let us just stick with this picture.red, right? Okay, so once we're done with that, we're gonna define our resources. We're gonna click on resources there, and let me just go to my lab guide. So our resources are 5. We have 5 resources. We have the lab technician that works at the department, blood bank department. We have lab technician that works at the hematology department. We have lab technician at the chemistry department. And then we have 2 resources that are our centrifuge. So we have your centrifuge at the blood bank, and then we have your centrifuge in the so we have a centrifuge that is used by the hematology department and the chemistry department. So you can realize that in this process, 2 departments are sharing a resource, a centrifuge, and that can also cause bottlenecks in your system, right? But I'm just gonna maybe see if I can show you a picture of a centrifuge. Maybe some might not be might not be might not know what a centrifuge is. So yeah, a centrifuge it's on the left, guys. It's there on the left. The centrifuge is that device. So blood samples, as you can see, the blood samples they are inserted into that centrifuge, and the technician does whatever he or she does, and then that centrifuge rotates, right? And they know, people that are doing chemistry, they know what happens, right? Then afterwards, once the sample comes out, it comes out looking differently. Yeah, then the technicians, they know what to do, but we're not concerned with that. I just wanted to show you how a centrifuge looks like. Thank you. And I think it doesn't only take in like blood samples. I've seen on TikTok they can put in maybe different kinds of samples. Yeah. Anyway, that's how a centrifuge looks like for those that didn't know. So under resource, we're gonna put in those resources of ours. I'm just gonna split my screens like that. Okay. So the first one is lab technician. Lab underscore technician that works in the blood bank. Then we create another one, lab technician that works in the hematology department. And then yeah, the capacity is 1 for everything, right? And then we have a lab technician that works in the chemistry. Department. Okay, and then we have our centrifuge. Centrifuge that is used in the blood bank department. And then let me just do this. What am I doing? Okay, we have also centrifuge in the that is used by the hematology department and chemistry department. Chemistry department. So yeah, all the type is fixed capacity and the capacity is 1. Right? So when we're done with that, we can go to our discrete processing, right? So remember, always we start with our create module, right? What did I name my create module? Sample arrivals. So we can name our module sample arrivals. And then we assign it our entity, which is samples. Then we are sticking to the random export type. Yes. Okay. So we are saying, okay, we're sticking to those times. Okay, we're saying our blood samples, they arrive every 1 minute. Okay, randomly after every minute. Then entities per arrival is 1, and then number of samples, the maximum number of samples that arrive in a day, we say it's 20, right? And then you can click OK, right? Then once we're done with that, because the 3 samples go to 3 different departments, use a decision flowchart module and assign the percentage of samples that go to each department as per specifications. In the scenario, use and weigh by chance. This option allows for multiple decisions if desired, right? So now we're about to introduce a new module, which is the decide module. So we're saying, what's this? Let me just go back. So we said 50% of samples go to the blood bank department. Okay. Then, okay, I'm just gonna say, okay, type is n-way by chance. Let me see, it's n-way by chance. Yeah, n-way by chance. Okay. So the first one is 50. Click. Okay. Let me just check something. Okay. Okay, so it's sample arrivals, and the name is, so under sample arrivals, under the decide module, you'll click n-way by chance, right? And then you click add, right? You'll click 50. The first one is 50, and then the second one is 30, right? You can just type it there, 30, if you don't see it there on your drop-down list, and click OK. And for the last one, you don't actually have to, yes. Between the process and decision. So your process is what's happening, right? The action that is happening in your whole process. And with your decision, this is where you decide on what happens to your entity. In this case, our entity has to go to three processes, right? It's samples. It's the samples. Yes. No, resources are not your samples. Your sample is your entity. Your entity, think of it as like something that you are doing an action on. So in this case, we are testing our samples. So in the previous example, the customer is the one we are working with, right, in your process. That is the entity. Your resource are your machines, your operators, and so on. Are you fine now? Okay, so now we are on the decide module. So because we said that this sample of ours goes to 3 different departments, we now have to use the decide module. So anything that has to do with decisions, that's when you use your decide module, right? So as I was saying, we have percentages there. Under percentages, we have 50 that go to what you call 50% of the samples go to what did I say? Blood bank, yes, and 30% go to hematology, and then the rest go to chemistry department. So I'm saying once you put in all your percentages there, you don't have to put in that one that goes to chemistry because the software does it for you. But for interest sake, let me just put it on. Let's just put it on 20 to complete the 100, right? Then let's just say decide. If you name your modules the same as the other modules, you'll get an error. Let's just demonstrate that. If you say sample, I might be wrong, sample arrivals, and click OK, you'll get this pop-up. Module name must be unique. So every module must be unique. So we just stick to decide one. Sometimes in your process, you might have multiple decide modules. So yeah, just bear in mind about that. So yeah, we can click OK. Okay, so if you can scroll, I'm scrolling now. If you can scroll, you'll see something. You'll see that on your decide, we have those 3 percentages that we assigned, 50, 30, 20. So you will connect each node to the respective department, right? So after this, what happens is we now put in our departments, right? Blood test, hematology test, and chemistry test. Right? So that is where we put in our decide our process. I mean, our process process modules. Okay. Okay. Let me just zoom out a bit. Let's zoom in or zoom out. Okay. So process 1, we said it's our blood test. Blood test. Okay. Huh? Thank you. Thank you, fellow colleague, for helping the brother there. Okay, remember the logic action is seize, delay, release. Then for this case, the resource we use, so this is a key part, right? So for your blood test, remember we have the technician that works here. So we're gonna go to under resource name, we're gonna go to lab technician for blood, and you click OK. But another resource that is used is the centrifuge. So immediately when you go to click add again, you'll see resource 2 there, but you'll drag down there, and then you'll go to centrifuge for blood bank. Oh, I see that is okay. Let me go back. We are on process, guys. Okay, the first one. We're on the first process, guys. So I was saying logic action is always seize, delay, release, and then we added a resource, which is the lab technician, right? And then we know that in this station we have 2 resources, the lab technician and the centrifuge, right? So you'll click add again, and then you'll go under resource name, you'll go and drag down and go to the centrifuge blood bank. Then you click OK again. Then you'll see under resources there you'll have 2 resources added there. And then we'll use a triangular delay type. And then, so I'll specify which delay type to use, right, during your test. So we'll stick to triangular delay type, and then units, it's minutes. And then we can stick to these parameters. So minimum, it takes 0.5 seconds to complete the test. Most likely it takes 1 minute, and maximum it takes 1.5. But because it's a centrifuge, right? Obviously, they always set it to a specific time limit, right? The machine works according to the time you set it. So if you can click on uniform, no. So if you can click on constant, let us use constant for this case, right? So our centrifuge, we set it to 3 minutes, right? For example, I'm making an example. So we can say it takes 3 minutes to test our blood samples, right? And then you can click OK. Then we're done with that. Okay, then we go to, before that, there's something I forgot to do under resource. Did I? Oh no, everything is fine. Okay, everything is fine. Okay, now we're going to process 2. In process 2, this is where this is the hematology test. Hematology test. Then the logic action is cease, delay, release. Then we add our resources. So in this resource, the first one, it's lab technician for hematology. And you can say, okay. Then another resource is centrifuge. Centrifuge for hematology and chemistry. So bear in mind, this centrifuge is shared by 2 departments, right? And then you click OK. And then, what's this? It's also constant. And then we say it takes 3 minutes, right? It takes 3 minutes to test our samples. Then you can click OK. Then lastly, we configure our chemistry test module. Chemistry test. Yes. Yes. We're getting errors. What is the error saying? Invalid symbol name. Can I just come and check it out? Oh, I think it's items. So, yeah. Yeah. Use a underscore instead. So yeah, because of that error, you have to fix that for yourself. We are continuing here. So the logic action is cease, delay, release. Huh? Yeah. So the logic action is cease, delay, release, and we add our resource. Our resource is lab technician chemistry. Click OK. Then the other resource is centrifuge ham chemistry. So the very same one that is shared. Then we can go to constant, and then we say every 3 minutes. That's how long. Oh, thank you. We have people that are paying attention. We have 3 minutes to complete your testing of your samples, and then you can click OK. Let me just double check if my minutes were consistent, or also here it was hours instead of minutes. So yeah, guys, just double check always that your units are consistent. And I'm gonna be looking out for such things when I'm trying to deprive you of getting 100%. So if you just don't do your units, I'm gonna take some marks there. Then let me check here, 3 minutes, and then it's minutes. So yeah, Then once you're done with that, you can now drag and drop your disposal module, right? Where are you? Where are you? Disposal, dispose. Okay. Misbehaving. Who told you to connect? Okay. So you have your dispose here, and you can. What did I name it? Packaging of samples, right? So once we're done with testing the samples, we package samples. Then you can click OK. Right, well now let's connect our modules. So how you do that, oh you know how to connect. So we're gonna connect our modules. So sample arrivals to decide one. And then, okay, now I see something. So remember I had said that you don't have to put in the 20. Let us just remove that because in place of the 20, edit, delete. So how you can delete that, you click on it and say delete, and then click OK. This is where the else, on the else, if you can check something there, on your decide, you have 3 of these nodes, 50, 30, and this one. So this else is the 20 that we are short of, right? So that's where we'll connect our other, that's where we'll connect to our other module, right? Okay, so I'm just gonna decrease that, and then we're gonna connect. So we're gonna connect the 50 to the blood test, and then we're gonna connect our 30% of our samples that go to the hematology, and then we're gonna connect else to our chemistry. So that is our 20, right? And then last is just to connect your processes to your disposal module. Okay, let's just try to make it look a bit neater. Okay. Okay, this looks much better. Okay, so that's the complete flow of your process, right? All that's left is setting up your parameters, right? So your replication parameters. Then let's say number of replications is 1, and then warm-up period is in minutes. Replication length is in minutes. And then hours per day, let's just say it's an 8-hour shift. And then base time units, it's just minutes. Then we click apply, click OK, then we're ready to run our simulation, right? So the icon that we should look out for is like of a report, right? Then you can click play and let us see. Oh, it's a red ball that we should see. Okay, so before you say yes, you'll observe that like here on your disposal, it's actually the 20 samples that we set, right? So, and you will also, yeah, it's the 20 samples that you set. And yeah, you'll get to see how many went to the blood test, hematology test, chemistry test in your descriptive analysis. So once you see this pop up, you'll just say yes. Then yeah, this is your category view, right? You can see that, oh, now it's configured correctly. It's now minutes, the type units there. So you can see that system number out is 20, right? Yes. Oh, to the packaging. Okay, how you do that? So how? So it's a matter of like going to home and clicking connect. Huh? This one. Or to connect. Okay, let me just go out of simulation mode. Is it this one? Run. Yeah, it's just a matter of if I can. You see, if I can just look at this, the one that I'm dragging, the last one. If you can drag it up, it will go there. But it's just a matter of aligning. Aligning. Sorry. Let me just show you. Okay, so go ahead and click run. So if you can go ahead and click run, yeah, you'll see. Yes, everything is minutes. So the simulation has run to completion. Would you like to see your results? Yes. Sorry? Yes, 8 hours. So we're mimicking like a normal shift of a person working. So under category overview, you'll see that the number out is 20. That is your samples, right? If you can go to category by replication, you can see that yes, we're only replicating once. We're replicating the simulation once. Now you can set it to 2, 3, 4, 5, 20. Oh, okay. Also, that one will specify. Yeah. Okay. Okay. So after that, we have our samples there, right? I mean, we have your data there. So we have your wait time. You have your value added time, which is so under time there, under value added time, that 3 average of 3, it means on average it takes 3 3 minutes to what's this, to run our samples through the centrifuge, right? And it won't change. It won't change. It's gonna be constant 3 minutes. And then non-value added time is just 0 there. Wait time for samples. Now this wait time, if you can remember, it's caused by those two departments sharing that resource, that centrifuge. So each department waits on average 3.2795 minutes before they can use the centrifuge. Sometimes it can take more. Sometimes it can take close to 7 minutes. Now, is that satisfactory? That's the question you have to ask yourself, right? Total time samples. So that's 6.2795. It's the total time that a sample like goes through the system, right? But at the top there, it is divided between value adding time and non-value adding time, right? Then, yeah, there's also total maximum time and total minimum time, right? And then WIP samples on average, so the average samples that wait in a queue is 3.7. So we can never have 3.7 samples. So we can round that off to 4 samples. And then the maximum that we can have at times is 7, right? And then, yeah, so on and so on. So this is another descriptive analysis based on your samples. Then we have frequency, nothing there. Processes, nothing there. Queues. So yeah, so this is another interesting analysis. So waiting time for the blood test. So the blood test queue has a waiting time of 3.13 minutes, and the chemistry test queue has a 3.71 minute, so it waits for 3.71 minutes. And then your hematology test, before it gets conducted, you have to wait 3 minutes, right? Number waiting. What's okay. This interpretation. Okay, can anyone find an interpretation for this under other? Yeah. Can anyone interpret what this section means under other? Because it talks to blood test queue, chemistry test queue, hematology test queue. Is it the average waiting time or what? Okay, you'll just study that and come with an answer, right? And we have resources. So we have your resource utilization or resource usage. So your centrifuge blood. So the centrifuge used by the blood department is seized 9 times. It's used to test 9 samples, and then the centrifuge that is shared by the hematology and the chemistry department is shared by 11 samples. Right? And then the scheduled utilization there, that has to do with like percentages, right? That's 0.8, it's just 80%. So in the blood department, blood bank, that device is used 80% of the time. But in the centrifuge hematology, it is utilized 98% of the time, right? And then the other interesting one is that the lab technician for hematology and what's this? And chemistry, it's at 0.53 and 0.44. What does that mean? That is because of the shared resource. So it's because sometimes the other technician is waiting and is not doing any work because the resource is being used by the other department. Right? So that's another interesting analysis there, an interesting figure there, right? So would you want this this increasing, this resource utilization increasing or what? Right? Do you want your resources being idle or do you want your resources having a higher usage percentage, right? Those are the questions you have to ask, right? Then, yeah. All right, ladies and gentlemen, that's it for today. Enjoy the rest of your evening. Any questions before we leave? Yes. Okay, let me just stop the recording and I'll attend those that raised their hands. 1.32.